Today, we're going to dive into figuring out properties and discovering the properties of spread by using Python.
Perfect. This is data science discovery, so we might as well.
And I feel like we want to begin with the same data set. Let's look at the properties of spread using the party data set. So we're going
Sounds
to load
good.
this in the same way we've loaded all the data sets in. Import pandas as PD, then df is equal to pd.read.csv. This data set is right here, loaded on my faculty website, waf.csa.illinois.edu/discovery/party.csv. And then we'll type df to just make sure the data set gets all loaded. And Carly, how's it going?
We are good.
Awesome. So we want to now find the standard deviation and variance of a variable. And this is a measure of how spread out this variable is. So one thing that I think is going to have just a bit of spread is I think couple is going to have a bit of spread. So I'm going to go ahead and write for the standard deviation. I can find the standard deviation of all variables by doing df.std, open close parentheses. And that stands for standard deviation.
All right. df.std.
And when you do that, so for couple, I think our data column is called, let me look up here, it's called a couple.
A couple.
So we're going to look at the variable a couple. And what is the standard deviation for a couple?
So the standard deviation for a couple is 6.3.
6.3 is the standard deviation. And then we're going to look at variance. So to find the variance in Python, you can do df.var for variance. And that's going to report the variance for every single variable in our data set.
And for a couple, we get 39.5.
39.5. And what I want to do is now I want to modify the data by adding a single constant to every single observation in the data. So we're going to make everyone who responded to a couple think that it's 2 more people at the party. So I'm going to add a constant value of 2 to each observation of a couple. So to do that, I'm going to take the data frame and look at the column a couple. And because it has a space in the variable name, we have to use the square bracket and quote notation. So df at a couple is equal to df at a couple plus 2. So now every single row in our data is having the couple value change from what it was to a new value. And now we're going to look at df.std one more time and find out what is the new standard deviation.
New standard deviation is 6.3.
6.3. And the new variance we can find out by doing df.var.
df.var. And we get for a couple 39.5.
39.5. So Carly, this is really interesting. Did we screw up?
Did I not do this right? Because they're both exactly the same.
So this is interesting. And I think that, so let me just first answer the question, then we'll kind of think about why this might have happened.
That sounds good.
So how did adding and subtracting the same number to all observations change the standard deviation variance? So I'm going to say the STD and variance, which I'm going to say is the spread, did not change at all. Oh, that's interesting. So do you have any insight for that?
Yeah, I like to think about the standard deviation first. So if we think about standard deviation, it's a measure of spread. And if we're adding or subtracting the same value to every number on the data set, I guess we're not really changing how spread out the data is. We're just shifting it over either to the left or to the right. So that kind of makes sense that it wouldn't change. And then variance is very related to standard deviation. It's just the standard deviation squared. So if one doesn't change, the other isn't going to change.
So I like to think of this with data, of course.
Classic.
So I think of like the numbers 2, 3, and 4. The spread of these is each number is spread out by having only a difference of 1 between the center value. And then if I add 2 to all of these, I now have the values 4, 5, and 6.
Yep.
And now we still have a spread of just 1 between the center value of those 3 values. So you can see just by adding a constant, we actually don't end up changing how spread out these values are.
Exactly. We're just, shifting them over to the right.
So now we understand how spread changes in addition. Let's do the same thing with multiplication.
That sounds good. And so for subtraction, it would be the same as addition.
Exactly.
So let's do multiplication.
So to find the standard deviation and variance of, let's think about a column that has a lot of variance. So looking at a data set, which one do you think would have a lot of variance? So Carly can just type DF to look at all of the different columns.
Yep, that's exactly what I did. And let's see. It looks like many has a lot of variance from what I can see. I see some people said 7 is many, some people said 80 is many.
Awesome. So we're going to look at this, find the standard deviation and variance of many before modifying the data. So I'm going to go ahead and say, now we can say df dot mini, capital M, dot std, open close parentheses, will report the standard deviation of the mini column.
And it is 24.1.
24.1. And let's look at the variance. So df.mini.var.
Variance is 581.3.
581.3. So before we even dive into this problem, I want to kind of observe how we went from a standard deviation of 6.3 to a standard deviation of 24.1 when we compare just couple to mini. What does that kind of mean? Why, when we have a value that's so much larger?
Yeah, so it basically means that when people were answering this survey, there were a lot of different values that they put in for many, and they're kind of more spread out. Whereas for a couple, it's probably that most of the data is kind of centered around the average and not super far out from the other numbers.
Awesome. So yeah, and then that makes a lot of sense. I think from just looking at this data, mini means a lot of things to a lot of different people. And you might think mini as 10, or you might think mini as 100. Well, a couple of people are going to say a number somewhere around 2.
Probably around 2. I definitely said 2.
And there's not going to be as many outliers or an extreme example of people saying a couple. So let's go ahead and modify this data set by changing the value of mini by, let's multiply everything again by 3. So I'm going to say df.mini is equal to df.mini, replacing the value of mini by a factor of 3. So I'm going to add the constant value of 3 to each observation of mini.
Sounds good. And now should I look at the standard deviation and variance?
And yeah, let's do the same thing. Let's do df.mini.std again to find out the standard deviation of mini.
So the standard deviation is 72.3.
72.3. And what about the variance?
And the variance is 5,231.5.
So wow, quite a bit of variance.
Wow. So these both changed this time.
It did. So how did multiplying and dividing all the numbers in the observations change the standard deviation?
It looks like for the standard deviation, it just multiplied by that number.
So if we take our data and we multiply it by a constant, we find the standard deviation also increases by a constant. Which, going back to the number example, if I think about 2, 3, and 4, and I multiply 2, 3, and 4 by 3, I get 6, 9, and 12. So we see that there used to be a spread of 1 between the median numbers, and now there's a spread of 3. So this makes a lot of sense that we have this increase of spread going on as we go from 1 to 3. So the variance, though, 581 times 3 is going to be something like 1,600.
Yeah, the variance actually increased by more.
So let's do a little division and see what factor it increased by. So can you do 5231.5 divided by 581.3 in Python?
Yep. So I'm using Python as a calculator, and I got, well, 8.999. So it increased actually by a factor of about 9.
Factor of 9. Interesting. So how did multiplying and dividing all of the data by a constant change the variance?
So this is actually interesting because the standard deviation and variance are related. We know that the variance is just the standard deviation squared. So the standard deviation increased by a factor of 3, and then variance actually increased by a factor of 3 squared, which is 9.
So when you have the data multiplied by a constant, we then find the standard deviation we find the variance is multiplied by the constant squared. And you'll even see in the symbol notation that we're going to be using throughout the series, we see that the standard deviation is represented by a sigma, and the variance is represented by a sigma squared.
Yes.
So this makes a lot of sense.
That's very common. You'll see that notation in statistics all the time.
Now let's look at a third property. Let's look at the sensitivity to outliers of the variance in their standard deviation.
Sounds good. Should we check about the negative numbers?
Oh, do you want to do that? Let's do it.
Yes, I think we should, because I'm just curious, since we're seeing that the mean and median had different properties than the standard deviation and variance. So I wonder if the negative number thing is the same.
So let's do that right now. And we've looked at many. I think sum is also somewhat like many.
Sure, yeah, let's do that.
So let's see if we modify. So let's find the original values of sum for both the variance and the standard deviation.
All right, so the standard deviation is 8.2.
And the variance?
And the variance is 66.9.
66.9. And now you wanted to multiply all of them by a negative number?
Yes.
So let's do -4 so we can make sure to see the difference.
Perfect. So I'm going to do df.sum is equal to df.sum times -4.
Exactly.
And then now I'll go, so I just ran that and I'll go ahead and find the standard deviation. And I get 32.7.
7.
2.
Interesting.
And then for the variance, I get 1070.37. So 0.4.
Oh, interesting. So we now see that by multiplying by -4, that we don't simply multiply the standard deviation by the constant, because 8 to 32 is certainly a factor of 4, but it's a factor of +4.
+4. Actually, that makes sense, because we know that the standard deviation can never be negative. It comes from the actual calculation of that number with the squaring and square rooting. So this property actually makes sense that we wouldn't get a negative number, because the standard deviation is a statistic that cannot be negative.
And if I look at the numbers again, looking at data again, I can see if I've got the numbers 2, 3, and 4, and I multiply by -4 now, I get -8, -12, and -16. And we see there's a spread of 4 between these numbers, not necessarily -4.
Right.
The difference between these numbers is still 4.
Negative spread doesn't really make that much sense.
So we can update our analysis by saying if we multiply all of the data by a constant, that's the same as changing the standard deviation, multiplying it by the absolute value of that constant.
Perfect.
And we can say the same thing with variance as well, but we also have the square operation, which you may recall actually is going to remove a negative number anyhow.
Exactly.
So often you don't see this absolute value here, because the number is always guaranteed to be positive. Now let's look at just one final property of outliers, and that is one final property, which is how sensitive standard deviation and variance is to adding a single outlier.
Sounds good.
So what's a new column that we haven't looked at? We've done some, many, and a couple. What do you want to look at?
Let's see. How about we look at a few?
A few. So A and then capital FEW?
Yep, that's exactly what it is.
All right, so we're going to look at the standard deviation and variance of a few. And because it has a space, now if we want to just look at a few, we need to do df at square bracket quotes a few quote square bracket dot std for standard deviation.
And we get 3.8.
3.8. And df of a few, getting the variance.
And the variance is actually 14.8.
14.8. Awesome. And now we're going to add a new record. And again, this is going to be a little bit of a crazy syntax. So we need to do df.append, and then we're going to open up parentheses, and we're going to open up a curly bracket and say the variable a few should have, so quote, inside of quotes a few, then a colon, and we're going to add an extreme value for a few. And I'm going to add the value, let's do 1, 2, 3, 4, 5, 6, 7.
Okay.
So 1,234,567, closing out the square bracket. Then we need a comma, and we have to say, we just want you to insert it anywhere. We don't care where it's inserted. So after the curly brace and the comma, we're going to say ignore index is equal to true. This allows us to sort of combine our data set values, which comes from our survey,
Mhm.
and a new value that we just want to hack in. We just want to stick it in there. So if we run this, you should see a new data frame with all of the data.
That is exactly what I see.
And at the very end, you see a new record that has a few to be 1.2 million.
It looks like yes, and the rest are missing. So
Awesome.
that's good.
And we're going to want to store this data as the new data frame. So before the df.append line, let's say df equals df.append. So we replace the old data frame with the new data frame with the appended value.
Just went ahead and did that.
Awesome. And this adds a new record of a few to the data set. And now let's look at the standard deviation and variance for a few to find out this last property.
Sounds good. I'm going to do df at a few. And again, this is one of those variables that has a space. So I'm using the notation with the square brackets. And then I'm going to do dot std open close parentheses. And I end up getting, whoa. Okay, 163,521.6.
Okay, so quite a bit.
Yep.
And then we know the variance is the square of that. So I'm
Yikes.
suspecting that that number is going to have 9 or 10 digits.
Okay, I'm just going to read this to you.
Yeah.
267,393,22523.3.
Thanks. That 0.3. So I'm adding commas in here, and it looks like it's so that's going to be thousands, million, 26 billion.
Oh my gosh.
So quite a variance. So how did adding a record to a few change the standard deviation and variance?
Well, it changed them. It increased them by a lot, but I'm not sure about the factor.
Yeah, so we can see that both the standard deviation and the variance, because the factor is going to affect it by how much other data there is, because the variance is going to depend on how much other data exists in the data set. We did notice that though, that both standard deviation and variance are very sensitive to outliers.
Yes. And they both change when you add an outlier.
Yeah, so adding a single outlier in addition to all of the different survey results we have has dramatically changed what our results were. So those are the different properties of measuring spread in a data set. And hopefully with the examples, you saw some little intuition of why changing the data changes the spread and how the variance in the standard deviation changes as you change the data.
That sounds great.